Hello again, this is Professor David Clough with you for our second boot camp in the use of Excel and VBA for problem solving in chemical engineering. The purpose of this boot camp is to introduce the Visual Basic for Applications, or VBA, programming language. And once we have the basics of that in place, we'll be able to move along and deal with our problem-solving scenarios and applications. You can see the outline that we have here for getting started with VBA. This is not meant to be a comprehensive introduction of VBA. What we will do is we'll put in place some basic information and techniques, and then you will use these in the subsequent boot camps 3 and 4. And we'll provide you with some references that will allow you to expand your knowledge as needed. So you can see the outline here. We're going to get started by talking about the settings, Excel settings for the use of VBA. We already went through these at the beginning of the first boot camp, but just in case you had jumped over that and came straight to this one, we will review them again. So I'm going to go over to the spreadsheet here so that we can review these settings. And the first, I'm going to File, down here, More for me, and Options, and then Advanced on the side here. And I want to make sure that there's no checkbox in the first option of after pressing Enter, move selection. This is pretty important when working with VBA programming, and especially recording macros for shortcut operations. So we want to make sure we have that set. And then we want to go down to the Trust Center here and come over to Trust Center Settings and Macro Settings, and make sure we have Enable VBA Macros selected here. And if you're not allowed to do that on your computer, you probably just want to select the next one up. But that is the one that we really would prefer to have. All right. And then moving on, things we want to come to Customize Ribbon and make sure over here that we have the Developer tab selected. Select that if you haven't done that. And then we want to come back and look at add-ins here, and down at the bottom, Go, and make sure that in addition to an Analysis Toolpack, we have Analysis Toolpack VBA selected, and then the Solver add-in. And we won't get involved with those with this particular boot camp, but they will come along later on. And I'll point out that a shortcut to get that dialog box is to hold down the Alt key and hit T and I. And that brings back that add-ins dialog box very quickly for you. Okay, so let's pop back over to our slides and just mention that we've been through checking those settings. And then one of the concepts when you're working with VBA and Excel is that they exist in two separate, very separate environments. So that presents a couple of challenges that we need to overcome. The first one is easy, and that is how we switch back and forth between the Excel spreadsheet environment and the VBA environment. And then later on, we'll be dealing with how you exchange information between the two environments. So, as noted here, perhaps the easiest way to do these switches is to use the Alt F11 shortcut key. Let's pop up back to the spreadsheet and see that if we do Alt F11, we switch over to the Visual Basic Editor, and this is how it's presented. We'll come back to it for sure in a little bit, and then we do Alt F11 to switch back to Excel. If we go to the Developer tab, all right, there is a Visual Basic command on the far left, and that gets us there, all right? And then over in the Visual Basic Editor on the toolbar at the left, there is a green X, which gets us back, all right? So we've got that available too. If we go back over to the Visual Basic Editor, all right, we see that it's laid out with different sort of areas or regions. The big gray area here is the code window where we enter program code. We have a standard menu at the top, and then we have a toolbar below it with different commands. And then we have something called the Project Manager here and the Properties window here, all right? So any of these particular items on the left can be removed, such as the Properties window. I just removed it. And then if we come along on the top, we'll find that there is a command for that with the shortcut key F4 that will bring that back. And likewise, there's a similar thing for the Project Explorer. But we generally keep these two open as long as they don't get in the way of our code. When we're working with the Visual Basic Editor, it's always important to be aware of the Project Explorer. And if we pop back over Alt F11, we notice that this spreadsheet or workbook is entitled Book 1, and the associated VBA code, Alt F11, is called VBA Project Book 1. So whenever we're working with respect to a particular workbook, we need to make sure that we have the appropriate project selected in the Project Manager or Explorer window. So that, and then we'll find that there are elements associated with that that we can open up by clicking the plus sign and the associated plus sign. Okay? So when we are going to create some freestanding VBA code, we can select the VBA project and then come up to the menu and go Insert Module. And this opens a code module. And so what we will do now is we will create a little program. All right. Now let us come back over to the spreadsheet, and in cell B2, I'm going to put in a formula equals PI with empty parentheses, and that displays the value of the pi constant in cell B2. Let's come back over, and we're going to write a tiny little VBA program, starting with the line sub test with empty parentheses. And as soon as I hit enter, you'll notice that it matched the substatement with an end substatement. And if you look closely, you'll notice that keywords are shown in dark blue in using the Visual Basic Editor. So what I'm going to do is put in a statement PI equals, and I will use the range type, and in quotes I will put cell B2. And then I'm going to use a built-in feature of VBA called message box or MSG box, and just do message box PI. So what I have illustrated here is that I have brought over a value from a specific cell on the only worksheet we have, and I have assigned that to a variable which belongs only to our sub-program here called PI, and then I'm using a message box to display that, okay? So what I'm going to do now is I'm going to come back and now I can run this from, especially useful when I'm developing it, I can run it from the Visual Basic Editor, and I can do that, you'll notice, and a menu command up here, run, which gives me several run options. You'll also notice that there is a right pointing triangle that's called run sub user form, and each of these show that there's a shortcut key F5 that runs this. So if I click F5, it goes back to the spreadsheet environment and gives me a little message box window and displays the value of pi to the full precision of 16 significant figures. If I click OK, I come back over here to that. All right. So this is a way to put in a very simple program, and then what I can do if I want is having the value of pi here, I can modify this. Let's get rid of this message box and let's put in r equals 5 for a radius, and volume equals 4/3 times pi times r squared. And then let's turn this around and do range B3 is equal to, now of course these operations we could have done very easily on the spreadsheet, but we're just illustrating simple things here so that you can get started. One idiosyncrasy that I want to point out to you is that in particular with VBA, you have to force and allow spaces around the caret symbol, which is used as exponentiation. Otherwise, it will not work correctly. And I apologize for that, but I'm afraid it's just the way that it is. And you'll notice here that we have turned things around. We've computed using a variable v, the volume of a sphere of radius 5, and then we are assigning that back to the spreadsheet in cell B3. So let's come back over to the Spreadsheet World and let us go to our Developer tab and click on Macros, and it opens a window, and for me it shows a whole variety of macros associated with a workbook called Personal XLSB. But then there's one down there which is called Test. And so I can attempt to run test, and it displays the volume of that sphere in the cell below B2. Okay? So we can run it from the spreadsheet. We can certainly come over and we can run it from the editor. As long as the cursor is anywhere in the code here, if you press F5, it will run the code. Okay? So what we're going to do now is we're going to move on and and illustrate how one can create a macro, which is a way to have a shortcut that you can use. And these are particularly important to you to streamline your activities on the spreadsheet so you can save a lot of time. So let's come back over to our spreadsheet. Let's get rid of these cells here. And what I'm going to do is I'm going to put in, excuse me, I'm going to put in some column titles or headers. Time in minutes. I'm going to put flow rate. And in parentheses, I'm going to put LPM for liters per minute. And then I'm going to have acidity, and I'm going to have that as pH. So I've got 3 column headings here. I'm selecting all 3 of them. And they don't look very good because they overflow into the next cell and then get cut off if there's anything in the next cell. And so what we would like to do, and this is very common when you're creating tables where you have numbers in a table and the headings above the numbers are longer and would require a wider column to display properly. So we want to have a way of formatting that. So what we're going to do here is we're going to create a macro that will allow us to do this with a single keystroke, okay? So to do this, I'm going to make sure I have the developer tab, and then you'll notice there's an option up here that's called record macro. And as an alternative, if we go way down to the status bar and over next to the word ready, there's a command icon that we can also click to begin recording a new macro. So if I click that, I get a dialog for record macro, okay? And so what I would like to do here is I will create a macro that I will call format heading, all right? And then what I'm going to do is I'm going to give it a shortcut key that I can use. And here we have to be a little bit careful because there are many shortcut keys already built into Excel. And there may even be a couple that are built into software outside of Excel. And we have to be careful with these because if we put something in, I'm not going to push enter on this, but if I put in Control C with a lowercase c, we know that we can use Control C to initiate a copy. Well, if I record this macro with a shortcut key Control C, this one will take over and Control C will no longer be able to be used to initiate a copy. So on a slide in a bit, we'll give you some guidance as to which letters to avoid and which ones to use, all right? So I'm going to use capital H here, and that immediately shows up as Control-Shift-H. And then you'll notice that it says store macro in this workbook, and there's some options. And this workbook, there's personal macro workbook, and there's new workbook. Now, we very rarely use new workbook, but when we are creating a macro that we're going to use in various settings with various workbooks, we want that to be stored in a personal macro workbook, and then it will be available to us, all right? It will be available to us from any workbook that we're using in Excel, all right? So I think that I already have a Control-Shift-H shortcut key for this. So let me come over. You don't do this, but I will. And I'll put in something like a Control-Shift-W for this. And then I'm going to click OK. And it looks like nothing's going on, but what we notice is up here, instead of record macro, it says stop recording. And down here, the same thing, it says a macro is currently recording, click to stop the recording. So what's going to happen here is there's an interpreter that's going to look at any actions that we take now, and it's going to attempt to write VBA code to accomplish these actions automatically. So what I'm going to do is right-click this selection of 3 cells and click Format Cells and go to the Alignment tab, and under the Text Alignment category, I'm going to select Center for Horizontal and Center for Vertical, and then I'm going to check the Wrap Text Control option, and I'm going to click OK. So now it has formatted my headings. So I'm done with this, and I'm going to click wherever I like. I'm going to click Stop Recording, and then supposedly I now have a macro that will work with this, all right? So what I'm going to do is come over here, and I'm going to put in another heading, valve position % open in parentheses. And I'm going to select that, and if you used H for your key, you want to do a Control-Shift-H. I use W, so I'm going to try a Control-Shift-W, and then it automatically formats the heading for me. Now, it's possible that I might need to come along and, fix it up a little bit, make something a little wider, and double-click to make it shrink the width of the row, but height of the row, excuse me. But this is the basic idea of creating a macro. Now, what is interesting is to see what in the world was the code that VBA wrote automatically for the macro. So let's go looking for that. Go over to Alt F11, and let me bring the size of this properties guide down a bit. And you'll notice, and you should have now, a project that's called Personal XLSB. So I bring that down, and I'm going to try to find a module that has, I have a number, so bear with me here. Here it is. And you probably only have one module. And this should show you the text that it created for the macro. And let's just talk about some general features here. Again, as we mentioned before, anything coded blue is a keyword. So our sub up here and our end sub, and then the name we put in for the macro is the name of the sub, and then there's some comments here shown in green, and the comments start with an apostrophe, the key under the quotation mark next to your enter key. And these are comments, and it put those in automatically, and it also included what the shortcut key is to remind us. And then there's some code, and this particular code uses a structure in VBA which is called with and end with. And what essentially it is doing here is it is saying with selection, and you can probably interpret that selection means any of the cells that are selected on the worksheet. You'll recall when we created the macro, we had 3. When we tried it out, we had 1. And then what it's doing is it's changing the properties of that selection. Now, it turns out that the only properties that we changed were the first three, with horizontal alignment, vertical, and wrap text. And the rest of these are the other properties on that alignment dialog panel. Then we did not change them. So recognizing that, if we would like to make this a little more compact, we can select those, and you operate the Visual Basic code window very much like a simple text editor. We hit the delete key and we can make our code more compact. Okay, so that is an illustration of how to create a macro. As I think you noticed, let's come back over to the spreadsheet and look at developer macros. And another way of doing that is should show a shortcut key here of Alt F8. So if I hold down Alt and hit the F8 key, I get the macro. And you'll notice that for me, I have a number of these macros. One, escape this, Alt F8. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I've got 11 different macros that I've created just because they are operations that I carry out over and over and over again. And that should really be your signal for creating a macro, is that if you are carrying out a multi-step procedure and then you realize, you know, I've done that 10 times already, then it's time to create a macro. Now, if the macro is only to be used in the context of the particular workbook that you have, then you want to associate the macro with the workbook. If it's going to be generic, then you want it in the personal macro workbook. So let's come back over to the slides and review that, and then we'll continue. This shows the layout of our windows. This shows the Project Explorer, all right, and how it's listed in addition to other projects, and there are others here that have to do with things that I'm working with. Here's one for the solver. This one here is for the analysis tool pack, etc. All right, and then we showed how to insert a module. And here I didn't do this, but this is a little one-line program, meaningless program that I've typed in here, subtest, and then run the program, and we get a dialog box that we can exit by clicking OK. And then here is the one that I actually illustrated for you live, and that was the one for reading a value from a cell into a variable and then displaying that variable over here. Noting that we can run subs with the F5 key. And then the second example was reading a value, making a calculation, and sending the result back to another cell on the spreadsheet. And I note here that a couple of things. One is that whenever you press the Enter key after typing in a line of code, the Visual Basic Editor will provide its own spacing. And so you don't have to use a lot of care in that, with the exception of this business with the caret, where you have to include a space either side of it. Otherwise, you'll get in trouble. And then this goes through the fact that we can run the sub using the F5 key or other ways from the editor. We can also run it from the spreadsheet using the macros command or Alt F8. And then here is the example that we had where I put in those three headers and selected them. And in this particular case, I show using a shortcut key, capital F. I happen to use a capital W. I think I suggested to use a capital H for U. And since it's a generic macro, we picked to store it in the personal macro workbook. Now, the next time that, if this is the first time you've ever created a macro in the personal macro workbook, whenever you close out that particular workbook, getting out of Excel, it's going to ask you whether you would like to save the macro or macros you've created in the personal macro workbook. And of course, the usual answer that you want there is yes. Otherwise, if you say no, they won't be saved and they won't be there the next time you launch Excel. Down here in the lower left, it says to avoid lowercase letters with the exception of these 6. And you can use almost all of the uppercase letters, and you shouldn't use F, as we did here, or O or P, all right? So that is your advice on which letters to use for macro. And quite often you want to pick a letter that means something that reminds you what it's involved, such as using the capital H for header, all right? And then this shows going through the steps that we did and then turning off the recorder, all right? And one of the more amusing things, which I certainly have been guilty of a couple of times in the past, is that you forget to turn off the recorder and you go on with all of your spreadsheet work. Well, as you do that, it will attempt to write VBA code for everything you do. And I think a long time ago when I got caught by this, I ended up with several thousand lines of VBA code that I had to delete. So always remember to turn off the macro recorder. This shows the code and the fact that there were only 3 lines of code and we really didn't need the default lines. You could have left them in there. They're just extra lines that don't do anything for us. The other thing I will mention here is the use of with and end with is just a little shortcut technique. And I could have removed with selection and end with, and before each one of these items that starts with a period, I could have entered the word selection over and over and over again. And the syntax for that is that selection identifies an object, which is whatever cells are selected on the worksheet. And then there's a period, and then there is a property associated by the object, like horizontal alignment here, and then the equal sign means that we assign the constant XL center to horizontal alignment. So instead of doing repeatedly selection 9 times, we use with and end with as just a little more compact technique. So, and this is what we ended up with. And a few comments here. Only create generic macros for frequently used operations. Macros particular only to the current project should be stored in this workbook. The macro recorder will sometimes get things wrong and you have to fix the code. All right, keep that in mind. We'll probably see that along the way somewhere. And with little knowledge of VBA, it would have been very difficult for you to write this code from scratch without the help of the macro recorder. But looking at the code in VBA, it's fairly easy to understand what it's doing. And this is the final comment, is that Excel will ask you whether you want to save the personal macro workbook. And the answer to that is that you want to do that. So I'm going to come back over to the spreadsheet and let me just click the plus sign here to get another workbook. And I'm just going to have some random numbers I'm going to put in here so we can use them for a purpose. So this is not that critical to what we're doing, but I'm going to go to the data menu and data analysis, random number generation, okay. And the number of variables is going to be 1. And I'll say the number of random numbers will be 100. And I'll say they'll be according to the uniform probability distribution between 0 and 1. And I'll pick output range, and I will select cell B2 here. And then I'll click OK. So now I've got 100 random numbers. If I go to the bottom of this, you'll see that it ends at 101. I've got 100 random numbers. And now what I would like to do, you know that when I'm on the spreadsheet, I can select this entire column with Control-Shift-Down. Right, tab and back tab to see the top, but Control-Shift-Down selects it. So what I'm interested in knowing is what is the equivalent VBA code that'll do this for me. And it turns out that it's not that easy to guess. You may be able to find it in a reference book. I'll point out one of those books at the end of our session. But you want to know what the code is. So what we do in that case is we use the macro recorder as what I call a code detective. So let's go to our developer tab and go to record macro. And in this case, I'm just going to, it says it's going to call it macro 2, and that's fine. I don't need a shortcut key. This is sort of a throwaway macro just to reveal code for us. And so I'm going to attach it only to this workbook, and I'm going to click OK, and then we're recording. I'm going to do a Control-Shift-Down, and then I'm going to stop the recorder. All right, let me go back, Control-Home. And now we'll come over to the Visual Basic Editor, and we'll go to our particular project, and we'll go, in this case, to Module 2 that it added in. And all it does is it gives us one statement that reads range selection, comma, selection.end, xldown.select. There's no way you would have ever come up with that. But now you know what it is, and you can grab this particular code, and you could copy and paste it elsewhere in another project, in another module, or anything, all right? So this is what we indicate on the next slide here, using the macro recorder as a code detective by just developing sort of a throwaway macro that indicates what is the code to accomplish something, and then we can copy that or make a note of it and use it after that, okay? So let's move on and consider an example, now a physical example, and that is to create, instead of subs, which stand for subroutine procedure, we want to create a user-defined function that we can use to calculate something of interest. Just like we would use the built-in functions in Excel, like square root or log or whatever, we want to create our own. So what we are considering here is to create a function that allows us to compute the volume of a cylindrical bin with a conical base. And we've drawn that here and indicated a radius r, a height of the cylindrical part, and a height of the conical part. And then we have shown the formulas for the cylindrical part, the conical part, and summing them in order to get the overall volume of the bin. All right? So let's come back over, and what we're going to do here is we're going to show you how we would solve this problem on the spreadsheet. And then we're going to show you how we can make it more portable by creating our own user-defined function to make these calculations. So let us come back over to Excel here. And I'm going to start a new workbook. You can either do that with File, New, all right, or I have it up here on my shortcut key list. And this is a new workbook, and I'm going to work with this here. So I'm going to come down to cell B2, and I'm going to type radius, HCYL, HCOON, all right, and volume, all right. And then what we're going to do with this, let me just justify these. What we're going to do with this is we are going to, instead of using cell addresses, we are going to use names for these cells. And names would be very much like variable names in an equation. So this particular cell here, I come up to the name box just above the letter A, and I'm going to type in radius. Now, this cell is still C2, but now it is the radius cell. If I'm somewhere else and I drop down the name box list and click radius, it will move to that, all right? Now, there's another way to create names, and I'll show you that, which we quite often do. In fact, I have a macro to do this because I do it so often, but we'll do it manually. And that is that I select a set of cells with labels, and I want to transfer these labels as names on these cells. So I go to Formulas, Create from Selection, and note that it says Create Names from Values in the left column, which is what I want, and I click OK. Now, whenever I do this, I click this particular cell, look in the name box, etc., and make sure the correct name has been created. Okay? And then what I'm going to do is put in some values, 1.5, and I'll use metric, so I'll say 1.5 meters. And then I'll say 3 meters for the cylindrical part, and 2.4 meters for the conical part. And then what I'm going to do, popping back over here, is that I'm going to implement these formulas in a simple single formula on the spreadsheet. So to do that, I'm going to do equals pi with empty parentheses. You know, that's the pi function on the spreadsheet that gives you the value of pi. And I'm going to do times, and I'm going to click up here, and you'll notice that it automatically puts in radius there, and I'm going to do caret 2. You'll notice on the spreadsheet we don't need to put spaces around that. And then it's r squared times height of the cylinder. Click there, and puts in the variable name or the cell name. And then I'm going to do plus pi again times radius squared times height of the conical part /3. Okay, so that replicates the formula, and I get about, let me bring down the precision a little bit here. I get about 26.86 cubic meters, okay? So that's what I have. Now, what I now would like to do is I'd like to replace this formula with something that is more portable. So I'm just going to create a formula that won't work here. I'm going to do equals bin volume, all right, with 3 arguments: radius, height of the cylinder part, and height of the conical part. And so that's what I want it to look like. Now, of course, if I hit enter, it has no idea what I'm talking about. So we have to create a code to implement this function. And it's not that difficult to do. This is book 2 for me. If I come over Alt F11 and look for, let me collapse book 1, look for book 2 here, then what I want to do is insert a module for book 2. And this is where the code's going to go. So now instead of sub, I start this off with function bin volume, and then I'll call it R, HCYL, and HCON. Now I do not have to have the same symbols here as I have cells named on the spreadsheet, because we are over in VBA World, and these are just variables that can now be used in the code, and they relate back to wherever the bin volume function is invoked. So first thing I'm going to do is I'm going to create a formula, 4 times ATN1, in order to compute the value of pi, because the function for pi, which we use over in Spreadsheet, is not available in VBA. You've got to remember that VBA is in a different world. In fact, in VBA, the arctangent function is ATN, whereas over on the spreadsheet, it's ATAN, or ATAN2. So what we're going to do now is put in a couple of assignment statements. Volume of the cylinder is equal to pi times R. Notice that I put spaces in here. R squared times HCYL. And then you'll notice how it reformats that. And then volume of the conical part is equal to pi times R squared times HCON, whoops, get that right, divided by 3. So there are my 2 parts. And the last part is I assign the result of the sum of the 2, VCYL plus VCON, the name of the function. All right, that's the key thing here. I assign the result to the name of the function, okay? Now, we'll see if we get in trouble here, if we do anything that's incorrect, but let us go back over, and you'll notice this has not updated. The use of functions on the spreadsheet will not update except under 2 conditions. One is that an input to the function changes value. The other is that if we edit the function or the formula. So if I hit the F2 key to edit this and then hit enter, you'll notice that we get the same answer, okay? That we got with our formula on the spreadsheet. And so now we have something that's portable, so I can come over here and I can do equals bin volume of radius of 0.2, a height of 0.4, and a conical height of 0.1. And that is the cubic meters contained for those arguments, okay? And if my units were feet, those would be cubic feet. So I can use this formula anywhere in the workbook multiple ways, and it's very flexible for me. So let's come back to the slides and review this. This shows how we set up the spreadsheet and use the formula on the spreadsheet in order to get our answer, all right? And we use names for the cells. And we want to, just as we indicated back in Bootcamp 1, we want to, wherever possible, use names for cells. And this is particularly important when you're using VBA code that references cells on the spreadsheet, because if you reference name cells by their names and not by cell addresses, if those name cells are moved on the spreadsheet by operations such simple as inserting a column or inserting a row, the VBA code will still work. Whereas if the VBA code references cell addresses, it will not work when you make those kind of operations on the spreadsheet. Okay? So here we say that we would like it to look like this. It doesn't give us anything because it doesn't exist yet. So we create the function, and these are comments that we made along the way, and I'm not going to repeat them. And then, as we say, the function can now be used elsewhere in the workbook. And you can use it with a cell address, you can use it with names, or you can use it with numbers, as we did for the second example that I showed you. Okay, so that brings us to a conclusion of this part of our VBA review. And what we're now going to do is we're going to move on and just deal with some of the details of the VBA programming language. So you have these as a reference. We're going to use some simple examples to illustrate them, but we're going to be looking at program structure in VBA. And so the two categories that we're going to focus on are selection, which can also be called decisions or if structures. And we've got 4 different varieties there we're going to look at. And then the second category we're going to look at are repetition structures, which can also be called iteration or looping structures. And so let us come back over to the spreadsheet and illustrate these with some simple examples, okay? So let's come back to our spreadsheet here. And if you would like, you can take this particular workbook, and I'll show you how I do it here. And I'm going to save it, all right? And let me put it in a particular place here. I'm going to take a moment to browse to a place on my collection of folders. Then you'll notice that this is being saved with an extension XLSM and not XLSX. And this is because it has VBA code associated to it. It might have looked like Excel workbook, but then it will not couple to the VBA code. So we have, if it hasn't assumed that, we have to change it to an Excel macro-enabled workbook with an extension XLSM, and I can just call this something like bin volume function example and hit enter, and then it's saved. And so I can close this, and this particular one where we used a code detective, I'm not going to save that. You could certainly do that if you wanted to. And back. So looks like I need to, excuse me for a second here. Launch Excel again. Start with a blank workbook. Now, I always find these cells here to be a little bit hard to read. Maybe it's my age, whatever. And so I like to change the zoom to 150%. And I do this almost all the time. So I have a macro using the capital letter Z or Z, and I do Control-Shift-Z, and it automatically shifts that to 150% zoom. Just another example of a macro that one can create. So going to come back, go back over, this is book one for me, Alt F11, and it's got some code here from the macros which I can X out. Collapse the macro one, come to VBA project book one, and I can insert a module, all right? And then I'm going to create a simple function to illustrate what we call the one-way if, or the if-then structure. So that's going to be function SGN SQR of X. What I'm doing here is I am squaring a value X, but then I'm going to carry the sign of the value through to the result. And there are different ways of doing this, but I'm going to use an if statement to do it. So I'm going to start by saying SGN SQR. That's the name of the function, so that's the result, is equal to X squared. And again, notice the spaces there. And then I'm going to say if X is less than 0, then, and then very important style-wise, I'm going to hit the tab key to get an indent inside the if structure. It's not required, but it's really recommended so that you can read your code later, especially if you have longer sections of code with many levels. So SGN SQR is equal to minus SGN SQR. And then back here, end if. Notice that when I hit a return on that, it puts in its own spacing. So here we have function and end function instead of sub and end sub. And we have if and a logical condition that's going to evaluate either true or false. If it's true, do this. If it's not true, skip by and just go to the end. So now, if I come back over to the spreadsheet, and I'll use a cell, I'll put in -9, and then I will do equals SGN. Now you'll notice as I start this, there's a tooltip that recognizes the name of the function in blue background underneath. So if I hit the tab key, it just completes that. And then I can refer it to the cell above, and I get -81. Now if I happen to change this just to 9, I get 81. So that's how that works. And let's come back over. And when you have something as simple as this, we can take advantage, instead of using 3 lines for the one-way if, we can actually just use a 1-line version of it and get rid of this end if. And it says if X less than 0, then do this, all right? So if I have that, hopefully if I come back over and make this -9, it still works, all right? And 0 should evaluate to 0, and 3 should evaluate to 9, all right? So that's an example of using the one-way if, all right? And either in a single line format or the 3-line format. Now it's more convenient when the if is true, if you have several statements, it's best to use the multiple line style, all right? Now, below this, we're just going to put in another function to illustrate the two-way if, all right? And I'm going to call this one function fanning with an argument RE. Now, what this meaning is that this function is going to compute the fanning friction factor for liquid flow, all right, based on the Reynolds number. And here we're going to use two alternatives. One is that it's going to be laminar flow below 2100 Reynolds number and turbulent flow above. And we're going to use smooth pipe, so we're going to use a shortened, abbreviated way to compute the turbulent fanning friction factor. So I'm going to say if RE is less than 2100, then, again, tab in, then fanning, name of the function, is equal to 16 divided by RE, and back over again, and then I use else, which is like otherwise, and I say fanning is equal to 0.079 divided by the Reynolds number, space, caret, space, to the 1/4 power. And then end if, okay? And that's called the Blasius formula for smooth pipes. And so we're either going to get 16 over the Reynolds number for laminar flow. And by the way, if you've got your code and you want to make it more understandable, right, you can put an apostrophe here and something like laminar, makes that green. And you can put an apostrophe here and put turbulent Blasius or whatever to explain things. Okay? So, sort of hope we got this right, but let's come back to the spreadsheet and let's get rid of these things. And let's just put a cell number for the Reynolds number here. And I'll put in 500. And then I'm going to transfer that label as a name on that cell. And I have a macro Control-Shift-N that does that for me, so I don't have to go to the menus. But you could go to formulas, cancel that. Formulas, create from selection, and do it, all right? And then I can just use a label here for FF for fanning friction factor and say equals fanning of RE, and it's 0.032, all right? Now, if instead I used 50,000, then we get a much smaller number, okay? And we use the other formula to do that. Another advantage of having a function like this is if I come over here and start with a Reynolds number of 1 and put in a formula equals up times 10 in order to get some decades of Reynolds number, I think 1 million is probably enough. And then I can do equals fanning of cell to the left and double click the fill handle, and I get all of the friction factors for all of those different Reynolds number values. So that's your example for that. And let's come back to the slides and look at those two examples. You'll see that the slides are helpful in explaining things. So we've got the if-then here, and you notice we indent, use the tab key to do that, or doing it in a one-line version. And this shows the two versions that we had for squaring something and preserving its sign. And then we have the if then else with two alternatives, and we showed that with the fanning friction factor example, okay? And then now we're going to go on to the third one, which is the multi-alternative if, or if then else if. And so let's come back over to the spreadsheet to illustrate that. And I'm going to go over to VBA, and you'll notice we can put multiple sub-programs here if we want, and we can also, if we would prefer, we could say, well, I think I'll put this one in another module, so I can insert another module here, since this example is going to be somewhat different, okay? So let us start another example. I'm going to call it function ATM-TEMP with H. Now, what I am doing here is temperature of the standard atmosphere versus altitude in meters. And you can find this on the internet. I'm just giving a little explanation of what's going on here, all right? And so I've got this function, and so what I say is if H is less than 11,000 meters, then T in degrees Celsius is equal to 15.04 minus 0.00649 times H, right? And then I have else if H is less than 25,000 meters, then in this case, T is constant, and it's equal to 56.46 Celsius, minus 56.46 Celsius. And then finally, I have else, all right? And that's if it's greater than or equal to 25,000. And in that case, T is equal to minus 131.21, all right, plus, in this case, it is plus 0.00299 times H. And then I have end if. So here the style is, if this is true, do this and skip to the bottom. If it's not true, check this. If it's true, then skip to the bottom. And if neither of these is true, this is the default or fallback. Now the else in many cases doesn't need to be here, and we can have as many else ifs as we need in order to cover the situation, okay? So that is what we have for that. And if we come back over to the spreadsheet here, sorry, Alt F11, and let me remove this just for the moment. And I can come in and say, what if I would like to know what the temperature is starting at elevation 0, and then I want to go all the way to 50,000 in intervals of 500 meters. So when you have a freestanding column, you want to use over here in editing fill series. Make sure we're going to make a column. The step value is going to be 500, and the stop value is going to be 50,000. And click OK. And we can just check, goes down to 50,000, starts at 0. And then I can come in and say equals ATM, TEMP of that. Oh, let's go back over here. Yeah, we made a mistake. And that is we forgot to assign anything to the name of the function. So I want ATM TEMP is equal to whatever the correct value of T is. It's not updated, but if I double click in the cell or press F2 and hit enter, now it is. And then if I double click, it will evaluate all of these all the way down to the end, all right? And for instance, if I did a Control A tab and back tab, you know how to do that, and insert and maybe go to a chart, I can make a chart of the temperature versus elevation in meters, and I can fix that chart up to make it look better, okay? All right, so that's the multi-alternative if, and now what I'm going to do is I'm going to take a little break, and then we're going to come back and deal with the rest of the program structure elements in order to complete this screencast, okay? So we're taking a break. Okay, well, let's continue and move on to the final selection structure or decision structure, which we call the select case structure, and we'll look at an example there. It's a prepared file, which is called temp out. So let me open that file. You can do the same. And let's look at the code. Now this has some different features in it. The first is that we make use of the input box function to get a couple of values from the user. And here we're using the select case structure, which is quite often used in menu-like applications. So we first use the input box function to get a temperature in degrees C. And then we use the input box function again to get a response, which is a letter, either A, B, or C, indicating that we want to convert to degrees Fahrenheit, Rankine, or, Kelvins or degrees Rankine. Here, you'll notice with the second input box function, we use the continuation space underscore, because this would be a very long line, and we break it up. And then we also use VBCRLF, which is a reserved constant for going down one line. CRLF is an old-fashioned terminology meaning carriage return and line feed. And so we go down and we ask for the letter A here, or the letter B, or the letter C, and then the user puts that in, and then we have a select case with the choice variable, and we have case A, B, or C. Now, in this particular instance, these are not handled in order the way that the multi-alternative if does. It just looks for any one that meets the requirement of choice and then executes that. And so we have the various formulas for converting the temperature to the variable temp out, and then we message box that temp out value. So this is an example of use of select choice. We don't use it that often in our engineering problem solving, but it can come in handy sometimes in developing applications that others are going to use. So we can run it from here with the F5 key, enter a temperature in degrees C like 100, and say we would like that A, and it's 212 in degrees Fahrenheit, and click OK. We can run it again, temperature in degrees C of 400, and ask for that in B kelvins, and it gives us the temperature in kelvins. So this is an example for you with the select case structure. And let's pop back and look at the slides on this. This was our example of the if else, if then else. This shows the general structure of the if then else if, and the example we used for the standard atmosphere and the temperature calculation. And there's a file there for you on that. And then we have the select case structure, which starts with select case and ends with end select, and has case, and it actually has the possibility for a case else if the response is none of these items. And that's in a file for you called temp out. So next we want to consider the repetition structures, and there are two of these, and the first of these is called the do loop. And the way there are variations on this that we do not introduce here because we don't recommend them. These are like the do while or loop until, and everything that we need to do with this type of structure can be done with what we introduce here. And so we essentially have a start with the word do and a termination with the word loop. And generally this structure is used when you need to iterate and you don't know how many iterations is going to be required. When we do, though, the number of iterations, we use a different structure, which we will introduce presently. So the idea, do, loop, and then we may have some statements, and we have to have at least one if statement with a condition that when it evaluates to be true, we execute the exit do, which comes down below the loop and continues. If that condition is false, we do these statements, we call them post-test, and then we loop back. Now, it's possible there's plenty of flexibility with this structure. You can have it without any pretest statements. You can have it alternately without any post-test statements. And you can have more than one if tests with the exit do. Usually it's fairly simple. And so we're going to illustrate that with a numerical method here that calculates the square root, and it's actually based on Newton's method, and it shows the general structure of the code here, but we want to go over and show it on the spreadsheet. So let's go over there. And let's open a spreadsheet. Which is called SQRT1 function. And it's called find the square root. Let's go take a look at the code here. Again, this is a function. It's got the end function statement down here. And you can see that the overall structure is a two-way if. And what we're doing here, we're checking and protecting against the user asking us for the square root of a negative number or zero. This algorithm won't work with zero. And if that occurs, then we return in the name of the function an error message. If x is greater than zero, we proceed and we execute this code. The code sets an convergence tolerance and a starting estimate for the square root at the value of x divided by 2. Now, if we're lucky, and we might get something that looks like that. If we started with 4, then 2 would be the square root. But generally not. So we come into this loop, and we don't know how many times this is going to run, but we calculate a new version of this estimate in the following way. The old estimate plus the x divided by the old estimate, that quantity divided by 2. And this is what comes from the Newton's method application. Then we calculate an error as the absolute value of the new minus the old over the new. We check that against the tolerance, and if it meets the tolerance, we exit. If it doesn't, we make the new into the old S and loop around and do it again. And finally, when we get out of this loop, we set the result equal to the name of the function. Okay, so that's the way that works. And you see here a combination of using an if structure, if then else, and a do loop structure with a convergence allowing an exit. So let's come back over, and you can see here, if we put in 625, we get a result of 25. If we put in 4, we get a result of 2. 2, we get a result of 1.414, etc. And if we put in minus 10, we get an error message, okay? And so we can get various results using this. Now, of course, this is just an illustration because obviously we have a built-in square root function, which probably uses a similar routine to what we just implemented with VBA code. But we use this as a as an example of the do and the loop. Now, the next we're going to take a look at is the for next loop, and that is what we use generally when we know the number of iterations that we want to run. So let's open a new workbook for that. And I'm just going to put a title here, Case Study with For Next Loop. This is book 2, so Alt F11. Let's find book 2. Here it is. And insert a module. And now we're going to write a very brief sub called case study. And so I'm going to start this with range B2, dot select. Now that's a little different type of statement. It identifies an object on being a cell on the spreadsheet. And instead of wanting to know a property of that object, like its value stored, it takes an action or applies a method to the object, meaning that it selects the cell. So we select cell B2, and then we're going to have a loop for I equals 0 to 100. Now this just means that we run this loop 101 times, and each time it goes through, we vary the value of I, 0, then 1, then 2, etc. So what I'm going to do is I'm going to calculate an x value equal to I divided by 100. That means x is going to go from 0 to 1, 101 values as we go through the loop. And then I'm going to calculate a function value, which is equal to cosine of x times arctangent of x. Okay. Now, there aren't that many functions in VBA that mathematical functions, far fewer than are over in Spreadsheet World. But we'll find out later on how to get around that. And what we're going to do now is I'm going to say active cell. That corresponds to the cell that's currently selected. Or if multiple cells are selected, it's the upper left-hand corner cell dot offset. This is the distance from the active cell that we're going to take. It's going to be I comma 0. What this means is row column. So it says move down I locations from the current active cell. And then if I want, I can put in value equals X. Now, it turns out that value is the default property, so you can leave that out, but I'm just making that explicit. And then I'm going to do the similar thing, active cell dot offset I comma 1. So that means move one column to the right and set the value of F into the cell just to the right of the value of X. And then we'll do next I to close the loop. And that what this is doing is it's completing a table with an X column from 0 to 1, steps of 0.01, and then the corresponding values of that function calculation for each X. So let's see how this rolls here, all right? I'm going to do something a little different here. And that is, the first thing I'm going to do is going to do view locals window. And that opens up a window down here where we can see values in our code. And then instead of hitting F5, I'm going to hit F8. And what that does is it single steps into the code so we can see what happens step by step. And it's very useful in debugging. So if I do F8 and F8, and now take a look, Spreadsheet World, I see that cell B2 has been selected. Let's go back. And then if I do F8, now my locals window shows I equal to 0. Keep going with F8. X equal to 0 and F equal to 0. And then it's going to display these two, supposedly. Whoops. Went someplace else. Didn't want it to go there. So hold on a second. Let's bail out of this and I need to close out a couple workbooks here. So let's do that. Let's close this one out. Now we're back to this. Okay, let's try this again. 8. Okay. Now I is equal to 1, X is 0.01, and F has a value, and it should be completing these. Let's see. You can see how it's completing the table over here. All right. So let's come back, Alt F11. Now I can just either abort this operation with the stop button here, or reset button, or I can continue all the way to the end with the play button or continue, and then it should have run the thing. So let's go back and we can see that we have all of our values down to the end. And then again, if we were really interested, we could come up and insert a quick chart to see what it looks like. All right. And I'm not going to take the time to stylize the chart. So this gives us the idea of using a for next loop to carry out a given number of iterations. Let's come back to the code. And I'm going to modify the code here, and I'm going to add a statement and say if f is greater than 0.4, then exit 4. So what I'm saying here is there's a way for me to bail out of the for loop if I put an if test in there and adjoin it to the exit 4 statement, just like I did with the do loop with the exit do statement. Now let's run this one. Wait a minute, let's come back over and clear this out. I can get rid of the whole thing, I believe, can I? Okay. Come back over and let's run the code here, F5, or now let's look what happened. Let's come down here ways. We see that it stopped as soon as the F value got above 0.4. So that illustrates how we can exit a for loop with a test before the for loop has completed all of its iterations, okay? Now, the next thing that I would like to do with you is just cover a couple of basic properties of this for next loop that can become a little bit confusing. So let's come back to our spreadsheet here, and you can save this if you wish. You can always create it again. I'm going to open a new workbook. And here we're going to just for next loop index examples. So let's do Alt F11 to come over. This is book 3. Let's insert a module in book 3. Let me get rid of the locals window for a minute. I could always bring it back if I want, and I probably will. And then we're going to have one example sub, which is for in next index example 1. And here we're going to do for I equals 1 to 10. And I'm going to take a variable sum, which starts equal to 0, and add I to it. So we're summing the integers from 1 to 10. And you may know the shortcut formula. It's I times I plus 1 divided by 2, which is 110.55. But let's just do that and then complete I. And then let's take a look at the values of I after we're out of the loop and the value of the sum. Okay, let's do that with a message box. Put I equals. Then I use an ampersand, which is called the concatenation operator because it joins strings or text strings. And I put in I converted to a string there, and then ampersand, and then sum equals space, and then another ampersand and sum. Okay, I think that's what I want. So let's run this, and we get that I is equal to 11 and the sum is 55. Well, we might have expected the sum is 55 because I calculated that ahead of time. But notice that when it comes out of the loop, the value of I is 1 past the limit of the loop. it was 11. And that's a little bit tricky, and you need to keep that in mind if in calculations you ever want to use the loop index after you get out of the loop, that it's one step beyond the limit. Now, let us vary that, all right? And I'm just going to take this code here and Control C to copy it and put it down here. And I'm going to edit it to make it example 2. And I'm going to say for I equal 10 to 1, so we're going down, so we have to put in a negative step. So I'm going to do step -3. And we're going to have, the rest of it's going to be the same. So let's run this with F5 and see what we get. We get I equals -2 and the sum is 22. So let's take a look at that. If it's going down by 3, it starts at 10, then goes to 7, then goes to 4, all right? Then goes to 1, and then one more than that is -2. So that's why it displayed -2. And the sum is going to be 10 plus 7 plus 4 plus 1, all right? Which should be 22. I believe it is. All right. So those are some examples with the for next loop that just to give you some familiarity with it and the fact that you can decrease an index. And we quite often use the for next loop in order to operate with arrays that represent matrices or vectors. You may see that as we get into our third boot camp. So the last thing we're going to look at here is how to deal with subscripts. So let us come back over here, and you can save this if you want. I'm just going to delete it. And you can save this as if you want to, all right? And this one the same, but I'm going to open a new workbook here. And what we're going to be exploring is array index base, all right, or subscript if you prefer the word subscript over base. So let us come over to our Visual Basic Editor, pick the project, which for me now is book 3. You can always go back and check that. I'm going to insert a module, and here we are. And so I'm going to call a subarray test, and I'll call it array test 1. You'll notice I always put those empty parentheses in code that we may deal with later on. Subs or subroutine procedures can be called from within VBA and can have arguments. But when the sub is called by Excel, it doesn't have any arguments, so we use empty parentheses there. And I'm going to use a dim, which is for short for the word dimension, and I'm lowercase a1 and uppercase b. This is just my style, 1, 1. And then I'm going to have an a with an index of 0 equal to 1. And I'll put a colon in here, and that's how you can have multiple statements on a line, if you wish. And a index 1 is equal to 2. And then I will have cap b indices 0, comma 0, B is representing a matrix, is equal to 1, colon, B 0, comma 1 is equal to 2, and then one more line, B 1, comma 0 is equal to 3, and then B 1, comma 1 is equal to 4. Okay? So this is a tricky part of using Excel and VBA with array indices. So what I want to do is bring back the locals window, and we'll see what happens as we do this. All right. So I'm going to step it with F8, and you'll notice that it brings up objects of module A and B. And if I open A, it gives me A0 and A1 that are currently empty. And if I open B, it gives me B0, which has also B0 and 01, etc. And so what you'll notice here is that the base index of these arrays is 0, right? And that's similar to what you have, for instance, in the Python programming language, but not what you would have in MATLAB, where base indices are 1. So as I single step this, watch what happens. So we see A0 equal to 1, A1 equal to 2, B0, B0, 1, 3, and 4. So it sets these up as we have them, and it's using a 0 base for the indices. Okay, got that? Now, let us finish this. And I'm going to copy this code over to inserting another module in this project. And I'm going to call it Array Test 2. And ahead of the sub, I'm going to put in the declaration statement option base 1. Now what this does is it automatically changes the index base from 0 to 1. And we do that very frequently in engineering and scientific calculations because we're used to indexing matrices and vectors starting with 1 and not with 0. So here, since I'm doing that, I have to declare the size of A to be 2, being 1 and 2. Likewise for B. And then I'm going to be setting A1 equal to 2 and A2 equal to, A1 equal to 1, A2 equal to 2, and then I will have B1, 1 equal to that, B1, 2 equal to 2, 2, 1, and 2, 2. Okay? So now when I single step this, what you will note down here is that A now has indices 1 and 2, B has 1 and 2, and the sub under B is 1, 1, 1, 2, 2, 1, and 2, 2. So now when I come up here and execute this, I get the same relative results, but they are according to array indices that are based at 1. So that's the important thing there. And so at this point, we really have one additional example to work with you on, but let me finish this off with F5. But let's go back to the slides and catch up, all right? So this was our do loop, and this is the code for the square root that we implemented and we discussed, and it's available to you as a file. And then we had a case study where we had a for loop from I equal 0 to 100 and produced this array of x and f of x. And then we put in the exit for to terminate that early, and it stopped as soon as the f went above 0.4, all right? So we did that. And then we had our index examples for the for next loop, 1 to 10, to point out that the index is one more than the limit when it's finished, with a sum of 55. And here the sum was 22. We're going from 10 to 1 in -3 steps, and that sum was 22, and the final index was -2, which is -3 beyond 1. All right, so we had that. And then these were the two examples for arrays. This one up here is the, let's come back. This one up here is the base 0 example. And then using option base 1, this is the base 1 example, which we more typically use, okay? So what we want to do now is show you a final example that shows you how we use some of these structures, the for loops, and the array indices in order to accomplish something on the spreadsheet. So let's come back over to our Excel spreadsheet and let's open file. I have to go find it here. Sorry. And this is called Find Max Location. Okay, so what we are going to do here is we are going to take any arbitrary block of cells, as long as it's rectangular. And what we want to do is we want to have code which finds the maximum value here and gives us the relative row and column of that value. Now, if you examine here for a bit, you will notice that for these values, it happens to be this one. So we would expect this to be row 5 and column 1. So let's go look at the function that we have developed that will do this for us. We're not going to take the time to type it in because it's relatively long. And then we'll discuss it, and then we'll show you how it works. Okay? So here we go. Alt F11. Find max location, double click its module, and here is the code. Let's get rid of the locals window and take a look at this. So you see option base 1, which we just discussed, and then a further declaration, which we use almost all the time in VBA code, is option explicit. And what that means is that any variable that you define within a block of code has to be declared. And so we'll notice here that there are a series of dim statements that declare the variables that we're going to use here. And in certain cases, it declares the type of variable, such as M and N are going to be integer variables, as are I and J, and Imax and Jmax, because they're just counting variables. And then the other thing you will notice here is that the argument to this function called maxloc is data array. In other words, it is an array of cells instead of an individual cell or value. So the way that this works is that we come down here and we find out the number of rows in data array, because it could be different from time to time, and the number of columns. And so this is done by naming the object and essentially a property of the object like rows, and then count is a method that gives us the number. So here we have the number of rows and the number of columns. And then we set a variable maxVal, which is declared up here. And the type isn't declared, so it can be whatever it needs to be, to the first item in the data array. Now that is 1, 1, because we used option base 1. And then we have nested for loops. We have an outer for loop that does rows from I equal 1 to m. M is the number of rows. And an inner loop that with j does columns, j equal 1 to n, where n is the number of columns. We come in here and we say, is the current item in the array greater than maxVal? If it is, that item becomes the new maxVal, and we save the locations under the variables imax and jmax. We do this all the way through until we're done, and when we're done, imax and jmax will be the location of the maximum value in the array. So we put those into an array called maxFind, which we declared to have 2 elements. And then we want to transmit maxFind 1 and 2 back to the spreadsheet. And we want, this is a little different because instead of returning an individual value, we're returning 2 values. So this is more like what we call an array spreadsheet. And if we try to send those values back, Excel will put them next to each other on a row. But we don't want that. We want them in a column. So we borrow a function from Excel. That's what we do with application worksheet function. And it's the transpose function, which makes the row maxFind into a column. All right. So there's a bit much there for you to see, but there's some new features. Let's come back over and let's put in here, let's select these 2, and then we're going to put in max loc, and then we're going to select this up here. Press enter, and it says that it's in row 5 and column 1. Now, if we were to change this value to perhaps 0.245, then it now says we're in row 2 and column 4, and it's identifying this value over here as the location of the maximum value. So that shows you how that works. And let's come back to our slides and cover a couple of additional details. So this is what we described in terms of putting together find max location, all right, as a function, all right. And there's a fair amount of work that goes on in VBA where you are looking at tables of data on the spreadsheet and you're wanting to locate things, find things, change things. So this shows you an example of this. And this is an example with a different set of numbers where it identifies this item here. It's 4 and 5 here. This shouldn't be here. It's actually this value just below it, 97766. And you'll see that on the slides that you get. And then just another thing that we mentioned and made use of in there is that you can borrow Excel's built-in functions in VBA by using the worksheet function, all right? Application.worksheet function. You don't really have to use application dot, and then you put in the function name and any arguments. So here are examples. Atan2, which is the 4-quadrant arctangent with x and y, borrowed into VBA. The average function, which can compute the average of all the elements in the data array. You could use something else like median. And then what we did in our example, we used transpose to transpose rows and columns of an array in VBA. So that's it for our introduction to VBA. We'll move on into Bootcamp 3 and be working with Excel, and we will augment Excel with VBA when it's appropriate, and you'll see more features and more examples. So this is the conclusion slide. We provide our own reference here and also an extensive VBA reference that has been around with different versions for 30 years. And it is the Power Programming with VBA book, which is a very comprehensive general reference to the VBA language. And then we make note that we have now introduced VBA and will be going on learning to use Excel to solve typical problem scenarios. So that's it for Bootcamp 2.